All right, let's do this large country tariff case algebraically, which is a tad more than I'd probably expect you to know how to do. As I said in class, it's the difference between an A and an A+ student. Still, it's useful to see how these effects play out and why. And the main lesson to get out of this is what happens in the world market. All right, here we go. Go back to the problem, and you see that the demand is 2,000, P equals 2,000 minus 0.5 QD, and Q is in tens of thousands. And then the supply is 500 plus 2 QS. So import demand is the quantity demanded minus the quantity supplied at home. And for that, to work that out algebraically, we need the demand and supply curves. Here we've been given the inverse demand and inverse supply curve. So let's work to get what we need. I've drawn out the home market graph, the US market, and there it is. And we can start adding that information in. We have 1,300 as the original price. We have initial quantity of 1,400 if you plug that 1,300 into the demand curve, and quantity supplied 400. Notice that the import demand is 1,000 as we would expect. With the tariff, price goes up to 1443, price paid by buyers. Quantity sold, quantity demanded, I should say, falls to 1,114. And the quantity produced at home rises to 471.5. And then the price that's actually paid to international sellers falls to 943. So now we're ready to do our welfare analysis. Start labeling areas A, B, C. Oh, yeah, sorry. A, B, C, D, E, F, G, H, I. All right, and consumer surplus under free trade, A, B, C, D, E, F. Producer surplus, G, H. Government revenue, 0. A, B, C, D, E, F, G, H. All right, under the tariff, consumer surplus falls to just A, B. Consumers lose C, D, having trouble here. C, D, E, F. Producers gain area C. C, G, H is now producer surplus, so they're up by area C. And government revenue is now E, I, which is an all new revenue. And what you see is that, I didn't fill this middle one out, A, B, C, E, G, H, I. And what we see here, the deadweight loss, we've got our usual negative DF, the production and consumption inefficiency, but that's offset by area I, which is that terms of trade gain, and that area I is bigger. We can see that area DH. In class, I'll show you I just plugged the algebra of calculating these areas of gain and loss, and I just used Excel to find the optimal tariff. I'll show you that in class. And I've drawn the export supply curve. The first thing you have to do to solve this kind of problem is to figure out what the import demand is. So going back to the world market, we have a y-intercept of 1700, and a slope of 2/5, -2/5. So that's going to be flatter than this. I'm not going to draw it to scale, I guess. And these are 10,000 bicycles, 10,000s of bicycles per year. And this is dollars per bike. All right, well, we need to solve for the market without a tariff, and what you find is, I'm not going to, well, I guess I'll show you that algebra. What you find is that price is 1,300 and quantity demanded is 1,000. We'll add all this information to our domestic graph in a moment. Now, to find the effect of a tariff, what you're looking for, I'll do it logically and then do it algebraically. So $500 tariff, $500 per bicycle, you're looking for the place where the price that buyers pay is exactly 500 higher than the price that sellers receive. So let's do that algebra. In the world graph, I wrote the situation, I can just write the numbers there. Price buyers pay goes up by 143. Price sellers receive goes down by 357. And you find that the quantity traded is about 643. Again, I'm rounding numbers right and left. So now we're ready to go back to the home country diagram. So to get the demand curve, we've got the inverse demand curve, P equals 2,000 minus, I'm just going to say Q over 2. If you rearrange, if you get the quantity demanded on the left-hand side and do the algebra necessary, you find that quantity demanded equals 4,000 minus P, minus 2P. So you do the same type of manipulation to get the domestic supply curve. The inverse demand curve, the inverse supply curve is P equals 500 plus 2 QS, and that means the supply curve is QS equals negative 250 plus P over 2. And so when you subtract the quantity supplied from the quantity demanded to get the import demand, that gets you to, I'll go ahead and write it all out, 4,000 minus 2P minus parentheses negative 250 plus P over 2. Now, watch out here. What students tend to do is make sign errors, so make sure you distribute this negative sign carefully and correctly. I'm going to erase that little dot. All right, when you do all that, when you do it correctly, you get that the import demand is equal to 4250 minus 5P over 2. And just because we're going to graph this all, it's relatively convenient to put that back into a inverse import demand curve, and that gets you to P equals 1,700 minus 2Q over 5. And I'm going to let you verify the algebra in that. Well, now we're ready to add this information to our graph of the world market, and then we'll probably come back to this workspace to do the algebraic analysis of the tariff. All right. Find the sheet where I've done that, yeah. So you've got this, we'll let P be the price buyers pay, and then sellers receive P minus 500. And the way we implement that algebraically is that P equals 1,700 minus 2Q over 5, or 0.4 Q. And then sellers get not P, but P minus 500. And that's what's equal to 300 plus Q. And when we rationalize that, the supply curve, or the inverse supply relationship is I add 500 to both sides to get 800 plus Q. Then I set quantity demand and quantity supplied are equal in equilibrium. It's just there's a $500 wedge between what buyers pay and what sellers receive. And so when you do the algebra here, it's just as easy to realize that this P and this P are the same in equilibrium. And we then know that 1700 minus 2Q over 5 is equal to 800 plus Q. And when you work all that out, you need a calculator, and I'm going to make I'm going to round just to 10,000s. Q is roughly equal to 643, and the international price that buyers pay is about 1443, and of course P minus 500 is 943. So we can implement that